Okay, so this problem says the diagram below shows the titration of a weak monoprotic acid by a strong base. The word monoprotic sounds funny, but it just means that there is one H and then some anion, as opposed to a polyprotic, which might be like H3PO4, that would have 3 protons. So anyway, monoprotic just means that there's going to be one equivalence point where the H's match up with the base that's being titrated with it. And then which points indicate, first of all, the initial pH of the weak acid, so that's right here, letter A, because that's before we start the titration. The pKa of the weak acid, now this is in the middle of the area of the most buffering. And so the reason you can find this, happens to be letter B right here, is because at this point we've had some of the acid, HA, reacted with some of the base. I'll just make up a base and we'll just say it's KOH. And then this has produced some water and it's produced some A minus right here. And then there's going to be some K plus. And this is going to do nothing in solution, this will do nothing in solution. And at this point right here, we're halfway to the equivalence point. At the equivalence point, there's equal moles of acid and base. At this point, we're halfway there. So if I were to do an ice table of this, I would say there's 10 moles maybe of HA. I'm halfway there, so there'd be 5 moles of this. None. Now I'd lose 5, gain 5 right here. I'd end up with 5, 0, and 5 right here. And at this point, halfway to the equivalence point, I have this thing called a weak acid, and I have this part of the weak acid that is now called the conjugate base. This thing is called a buffer. And a buffer's pH can be found by doing pH is equal to pKa plus the log of the base over the acid. Now, if the acid is 5, and the base is 5, that should be pointing here, and the acid is also 5, then I have 5 divided by 5, or 1, and the log of 1 is equal to 0. And so that's the point where the pH is equal to the pKa, which is halfway to the equivalence point right there. This only happens when you have a weak and a conjugate of the weak. Now 102 says the equivalence point of the acid-base titration, that'd be right in the middle here, which is letter D. That's where equal moles of acid and base are present. And then the point at which all acid has been neutralized and only the base remains in the reaction, and that's letter E right here, because we've had all of this become now 0, and there's probably some KOH left over, so maybe we added like 11 moles of this or so, and I'd end up with 1 of this, and I'd have some of this stuff over here. Well, it'd be 11 amount over here, because, I'm sorry, 10 amount over here, because I'd lose 10, 1 left, 10 plus 10 over here. Anyway, we'd have excess KOH or excess of the base up there. All right, there's a little bit of the intra workings of a titration curve.